Imagine the universe is speaking to us. Not through the light of stars or images of the cosmos we know, but through invisible waves that literally pass through everything, even you, right now. In 2015, we heard these waves for the very first time, gravitational waves. They were the echoes of two black holes colliding over 1 billion years ago. But that was just the beginning. What else have we discovered thanks to them? Could they answer questions physics has yet to solve? And what if these waves reveal secrets that will change the way we see the universe forever? Welcome to my channel. In today's episode, you'll learn what gravitational waves really are, how we discovered them, and what mysteries they've already unveiled. Ready to embark on a journey into the depths of the universe? When we detected gravitational waves for the first time in 2015, it was like opening a new sense. Until then, we had been observing the cosmos with our eyes. Now we began to listen to it. But what did we actually hear? The first signal we recorded came from an event that occurred over 1 billion years ago. Two black holes, each tens of times more massive than our Sun, collided, creating a wave that traveled across space and finally reached Earth. In that single moment, more energy was released than all the stars in the observable universe combined. Incredible, isn't it? But that was just the beginning. Gravitational waves have revealed phenomena we never even imagined. For instance, did you know that there are black holes so massive that their existence defied previous theories? It was precisely such objects that we detected through subsequent signals. The most groundbreaking discovery, however, was that of neutron stars. Imagine an object more massive than our Sun, compressed into a sphere the size of a city. When two of these stars collided, the impact produced gravitational waves as well as bursts of light that we could observe with telescopes. It was during this event that we confirmed how elements like gold and other heavy metals are formed in the universe. Yes, the jewelry you wear might literally have originated from a cosmic explosion billions of years ago. Now, here's something even more mysterious. Gravitational waves are starting to reveal things we can't detect in any other way. For example, strange, isolated signals whose sources we still don't understand. Could they be new types of black holes? Or perhaps something even more exotic? In one instance, we detected a wave that might have been caused by the collision of a black hole and a neutron star. It was like a cosmic clash between David and Goliath, and its implications remain a mystery to this day. Gravitational waves also allow us to explore the farthest corners of the cosmos, regions where light hasn't reached us because it was absorbed by gas, dust, or other barriers. Yet, gravitational waves pass through everything, carrying information from these otherwise inaccessible areas. What else might they reveal? Could we uncover what happened in the first few seconds after the Big Bang? Perhaps these waves will bring evidence of extra dimensions, or prove that our universe is just one among many. Thanks to gravitational waves, we're asking questions we never even knew how to ask before. Gravitational waves have opened a new chapter in science, but, as with any groundbreaking discovery, they've raised more questions than answers. Some of these questions sound like the premise of a sci-fi movie. But are they really just fantasy? The first mystery revolves around black holes. As we began detecting gravitational waves, we stumbled upon something extraordinary. Many of the black holes we observed were larger than theorists had predicted. Could it be that the universe creates black holes in ways we didn't know about? Or are there entirely new mechanisms at work that we have yet to understand? And that's just the start. There are signals that remain controversial to this day. In 2020, we detected a gravitational wave that seemed to come from something that didn't fit any known scenario. It wasn't a black hole, nor was it a neutron star. So what was it? Some scientists suggest it might have been a completely new type of cosmic object, perhaps a hypothetical quark star, even more exotic than neutron stars. This is where the real controversies begin. One theory posits that gravitational waves could reveal the existence of extra-spatial dimensions. If the universe truly consists of more than 3 dimensions, gravitational waves might interact with them in ways we could detect. Imagine discovering that the reality we see around us is just a fragment of a much larger existence. Even more intriguing are the questions about the origins of the universe. Einstein's theory of gravity describes the cosmos on a grand scale, but it breaks down in the first fractions of a second after the Big Bang. Could gravitational waves reveal what happened in that enigmatic moment? Perhaps they hold the key to understanding how everything around us came to be. And what if gravitational waves point to something even more extraordinary, that our universe is not the only one? Some scientists speculate that echoes of gravitational waves could provide evidence of other universes in the so-called multiverse. Gravitational waves are signals generated when something truly extreme happens in the universe. Imagine 2 neutron stars, small but unimaginably dense, each more massive than the Sun but the size of a city. As they orbit each other, their motion literally ripples the fabric of space-time, sending out gravitational waves. These waves are like ripples in the very structure of the universe, stretching and compressing space and time as they pass through. Fascinatingly, these waves are everywhere. At every moment they're passing through Earth, but they're so subtle that we need the most precise instruments in the history of science to detect them. LIGO and Virgo, giant interferometers, capture these waves by measuring changes in distance smaller than the diameter of a proton. Thanks to them, we can listen to the cosmos, from dramatic collisions of neutron stars to other unexplained events happening billions of light years away. Gravitational waves might sound like a mix of magic and science, so it's no surprise that a lot of myths have arisen around them. Let's clear up some misconceptions. The first myth. Gravitational waves are dangerous. Sounds scary, right? While it's true that these waves pass through Earth, their impact is so tiny that they change distances between objects by less than the width of an atomic nucleus. In reality, their existence doesn't disrupt our lives at all. Without advanced instruments, we wouldn't even be aware of them. Another misconception. Gravitational waves are just a scientific curiosity. Some believe this research has no practical value. In truth, the technology developed to detect them has real-world applications. For example, the interferometric lasers used in detectors like LIGO are foundational in modern measurement systems for medicine and engineering. And now, one of the most popular myths. If we can't see gravitational waves, how do we know they exist? The evidence is undeniable. Beyond measurements from LIGO and Virgo, gravitational waves have also been confirmed through observations of cosmic events, like neutron star collisions, which emit both light and waves. We've seen and heard the same event on two different frequencies. Gravitational waves are more than just a physical phenomenon. They're a new tool that allows us to view the universe in an entirely different way, to hear stories that were silent until now. Every new wave we detect is another step toward uncovering the mysteries of the cosmos. If this episode inspired you to see the universe in a new light, don't forget to leave a like and share your thoughts in the comments. What do you think we might discover next, thanks to gravitational waves? And if you want to stay updated on our cosmic journeys, be sure to subscribe to the channel and hit the notification bell so you don't miss the next episode. Thanks for watching, and see you in the next video.